What if you could teach a computer to recognize objects in pictures? You're about to learn how. Computers can already see and understand images, but how did they learn to do this? It's an amazing story that started with a few key discoveries. You're about to discover the 3 most important milestones in the history of convolutional neural networks, or CNNs for short. These networks are the backbone of computer vision, and they've changed the world. Let's dive in and explore how they work. Imagine you're trying to recognize a picture of a cat. You might look at the shape of its ears, the color of its fur, and the shape of its eyes. A CNN works in a similar way. It looks at small parts of the picture, like the edges and textures, and uses that information to make a guess about what the picture is. But instead of using your eyes and brain, a CNN uses many layers of artificial neurons to process the information. These neurons are like tiny workers that look at the picture and say yes or no to different features. Let's see how this works in more detail. The first milestone in the history of CNNs was LeNet, developed in the 1990s. LeNet was a simple network that could recognize handwritten digits. It used a technique called convolution to scan the picture and extract features. The next milestone was AlexNet, which won a major competition in 2012 by recognizing objects in pictures with incredible accuracy. AlexNet used a deeper network with more layers, and it introduced a technique called dropout to prevent overfitting. The third milestone was VGG, which used an even deeper network with smaller convolutional layers. VGG was able to recognize objects in pictures with even greater accuracy, and it's still used today in many applications. Let's see how a CNN works in practice. Imagine we have a picture of a dog, and we want to recognize the breed. We can use a CNN to scan the picture and extract features, like the shape of the dog's ears and the color of its fur. The CNN can then use these features to make a guess about the breed. For example, if the dog has floppy ears and a brown coat, the CNN might guess that it's a Labrador Retriever. We can use a tool like TensorFlow to build and train the CNN, and then use it to make predictions on new pictures. It's an amazing process that's used in many real-world applications, from self-driving cars to medical diagnosis. So why do CNNs matter? They've revolutionized the field of computer vision, and they're used in many applications that affect our daily lives. For example, self-driving cars use CNNs to recognize objects on the road, like pedestrians and other cars. Medical diagnosis uses CNNs to analyze images of the body and detect diseases. Even social media platforms use CNNs to recognize faces and objects in pictures. It's an exciting field that's constantly evolving, and it's changing the way we interact with technology. So what did we learn today? We learned about the 3 most important milestones in the history of CNNs: LeNet, AlexNet, and VGG. We learned how these networks use convolution and dropout to recognize objects in pictures. And we learned how CNNs are used in many real-world applications, from self-driving cars to medical diagnosis. It's an amazing field that's constantly evolving, and it's changing the way we interact with technology. Let's recap the key points. CNNs use convolution to extract features, they use dropout to prevent overfitting, and they're used in many applications that affect our daily lives. Next time, we'll explore how CNNs can be used for more complex tasks, like image generation and object detection. We'll learn about the latest advancements in the field, and we'll see how they're being used in real-world applications. It's going to be an exciting lesson, and you won't want to miss it. Be sure to subscribe to our channel for more lessons on AI and machine learning, and hit the notification bell to stay up to date on our latest videos.